Electricity transmission involves moving large amounts of power over long distances. This requires high voltage levels to minimize energy loss. Overhead lines typically operate at voltages ranging from 115 kilovolts to 765 kilovolts, or even higher in some systems. These lines consist of bare conductors made of aluminum conductor steel reinforced, suspended from tall towers. Conversely, underground transmission lines utilize insulated cables buried beneath the surface. These cables often operate at voltages between 69 kilovolts and 500 kilovolts. The choice between overhead and underground transmission depends on various factors including cost, environment, and technical considerations. This essay delves into the advantages and challenges of each approach, examining their impact on reliability, cost, environment, and efficiency. Ultimately, the goal is to provide an informed perspective on the future suitability of both overhead and underground lines in the ever-evolving power grid. Overhead transmission lines have long dominated power grids due to their cost-effectiveness and ease of maintenance. Constructing overhead lines is significantly cheaper than installing underground cables. This is primarily because overhead lines require less material and labor for installation. Maintenance of overhead lines is also relatively straightforward. Visual inspections can easily identify potential issues, and repairs or replacements can be performed without extensive excavation. However, overhead lines are susceptible to weather events. Storms, high winds, and ice accumulation can cause damage, leading to power outages. Moreover, the visual impact of overhead lines often raises aesthetic concerns, especially in scenic areas. Underground transmission lines offer significant advantages in terms of visual impact and resilience to weather. Buried cables are invisible, preserving the aesthetic appeal of the landscape. They are also immune to most weather events, reducing the risk of weather-related outages. However, installing and maintaining underground lines presents considerable challenges. Underground installation requires extensive excavation, which is costly and disruptive. Locating and repairing faults in underground cables is complex and time-consuming. The confined space within underground installations also leads to heat dissipation issues, potentially limiting current carrying capacity. Section 4. Comparing reliability, cost, environmental impact, and efficiency. Overhead lines generally offer higher reliability than underground lines, particularly in areas prone to earthquakes. This is because overhead lines are more flexible and less susceptible to ground movement. However, underground lines are more resilient to surface-level disturbances, such as vehicle accidents or vandalism. Cost-wise, overhead lines remain significantly cheaper to install and maintain than underground lines. The cost difference varies depending on factors like terrain and population density. However, underground lines can offer long-term cost benefits in densely populated areas where acquiring right-of-way for overhead lines is prohibitively expensive. Environmentally, overhead lines have a visual impact and pose a risk to birds. Underground lines have a smaller visual footprint but can disrupt ecosystems during installation. Energy losses are generally lower in underground lines due to the absence of corona discharge, which is a phenomenon that occurs in high-voltage overhead lines. Section 5. The Future Grid. A Balanced Approach. Looking forward, a balanced approach that leverages the strengths of both overhead and underground transmission will shape the future grid. Overhead lines will likely remain the preferred choice for long-distance transmission in rural areas due to their cost-effectiveness and ease of maintenance. In contrast, underground lines will play an increasingly important role in urban areas and environmentally sensitive locations. Technological advancements such as high-temperature, low-sag conductors for overhead lines and improved insulation materials for underground cables will further enhance the efficiency and reliability of both transmission methods. Ultimately, the optimal choice will depend on a careful assessment of the specific requirements and constraints of each project.